What's up guys, MizzoFrizzo from Pitchfork Academy here, and in this Unreal Engine 5.6 tutorial I'm going to show you how to vastly improve the camera from the third person template project. So as you can see here, I've got the third person template character and the camera is vastly improved. I've added an offset here so that the camera is over to the right hand side of the character, and no matter where you're looking, the character will always stay on the left hand side of the camera. And I've also added a slight offset here so that the camera no longer slides along the ground when you look up. There's a slight vertical offset here, so if you have grass or something in your game and you don't want the camera clipping through the grass, this will help solve that problem. I'll also be showing you how to add a clamp to how far you can look up and down with your camera. So this is clamped to positive 70 and negative 70 degrees. So you can't look all the way up or down. And as a bonus, I'm also going to be showing you how to add sensitivity controls for looking and also for aiming. So if I press the right mouse button here, you'll see we've got this aiming mechanic where the field of view is tighter, the walk speed of the character is lower, and the sensitivity of the camera is also lowered, and the movement of the character is changed depending on whether you're aiming or not. So when we aim, the character will rotate to look wherever the camera is facing, and if I release aim, she'll go ahead and start moving freely again. But just before we get started, guys, I'd like to invite you all to join our free and public Discord server, the Pitchfork Academy. It's a space we've created where you guys can get together and discuss our tutorials, look for help, and mix with other like-minded people. I'll leave the invite link in the description and in the pinned comment, but without further ado, let me show you how to do this. Alrighty guys, now I'm using Unreal Engine 5.6.1 and all I've done is create a new project using the third person template. And if I click play here and take a look at how the camera works, you'll see it leaves a little to be desired. It's kind of centered right behind the character. And if we, for example, look up and the camera boom collides with the ground and pushes in, you'll see it gets very, very close to the ground. So if you have any grass or anything sticking up off the ground, you know, it doesn't look great. And also the camera is just very, very centered and can look all the way up and down. So depending on your game, obviously, you know, you might want to do your camera setup a little bit differently to what I do in this video today. But I just wanted to give you a few tips on how to improve this camera. So first of all, if we head on down to the third person folder and blueprints, because I'm working in 5.6.1, I've got this BP third person player controller class, which was not in any previous versions of the third person template. So if you don't see this in here in the third person and blueprints folder, don't worry, I'm going to walk you through creating one of these in a moment. But firstly, let's just go ahead and open BP third person character, and I'm going to head to the viewport here and take a look at how the camera boom and the follow camera are set up here. And if we take a look at the camera boom, this type of component is actually called a spring arm. So if you add a component here, you would actually have to search for spring arm and add this, but for some reason in the third person template, they've renamed it camera boom. And when we move the mouse or the right thumbstick on gamepad and we look around, basically this camera boom swings around at whatever angle from this sort of point right here where it is attached on the capsule component. And with the camera boom selected, if we have a look over here in the details panel, there's a couple of settings we can change here to improve how this spring arm works and how the camera looks and feels compared to how it's set up by default in the third person template here. The first thing we can do is change the target arm length here. 400 is actually quite long, and I suspect it's set like this by default because of the way that the camera is centered on the character they just move it a little bit further back so that you can sort of see around the character a little bit more. But I'm just going to reduce this to 300. And also, just before we move on to the position of the camera, I'd like to point out down here in this section called lag, that you've got these options to enable camera lag and enable camera rotation lag. And basically what these do when you enable them is when you move the camera and you move your character around, the location of the camera is interpolated, and if you check enable camera rotation lag, its rotation is also interpolated. And once you check these, you get the option to change the camera lag speed and the camera rotation lag speed. And this is basically the interpolation speed that the camera will change its location and its rotation. So I like to check both of these and then pump up these speeds right here. I'll put the camera lag speed at 20 and the rotation lag speed at 50. And that means that, when we move our character, the camera's location will have a bit of lag to it. And when we rotate, there'll be a little bit of lag, but it will be very, very snappy. You don't want this rotation lag speed to be too low, or it might have a bit too much of a floaty feel when you look around. And now previously in other tutorials, when I've gone to sort of change the alignment of this camera, I've used socket offset here. So for example, if I put 75 in the Y and 50 in the Z axis, you'll see that the camera boom here is still going straight over to the camera here, but it has this sort of offset over to the side and up a little bit. But I'm going to show you a sort of problem that this causes. If I hit compile now and I hit play, you'll see that the camera is indeed offset over to the right and up a little bit. But if I look up and the spring arm collides with the ground and then it starts to push in, you'll see that camera starts to push in very close to the character, and it doesn't really stay over to the side. It sort of pushes right in, and then it's clipping with her right leg there. So it doesn't look great. And like I said previously, this is sort of how I did it in my beginners tutorials. But if I actually reset this socket offset here and leave this at 0, what I've found to work much, much better is if you select the follow camera and you actually just change the relative location compared to the camera boom of the follow camera. So if I put in the exact same figures here, 75 on the Y and 50 on the Z axes, and then I select the camera boom again, you'll see that we've got the same offset with the camera, except the camera boom is still pointing right back to this position right here. And if I hit compile now and I hit play, you'll see we've got this exact same offset, but now when I look up, the camera just pushes in on the right hand side of the character like so. So it doesn't matter if I'm looking down or looking up or wherever I'm looking, the character will still be sort of over on the left hand side of the screen, which is a much more sort of a nicer feel for a third person camera. And you'll also see that the camera is no longer sort of sliding along the ground like it was before. It's got that 50 unit offset because the camera boom is actually colliding with the ground here, but the camera is offset 50 units above the end of that camera boom. So if you did have grass on the ground here, like you're in an external environment with grass and vegetation, you'd have a little bit of a buffer there, and the camera won't necessarily just be sort of in the weeds on the ground when you look up. So I think that is much, much nicer. The next thing we can look at is sort of clamping how far up and down this camera can look. And this is where the player controller class comes into it here, because the player controller class has a setting in its class defaults, which is a reference to the player camera manager. Now, as I said earlier, this player controller class is non-existent in previous versions of the third-person template. They just use the sort of base player controller class. But if we have a look in the world settings here, And if you don't have the World Settings tab, you can just go to Window and World Settings. And I like to dock my World Settings tab over here next to the Details panel. You'll see here under Game Mode, we've got Game Mode Override, and we've got the BP Third Person Game Mode right here. If we drop down Selected Game Mode, these are all of the classes that are set inside of whatever game mode is selected right here. You can see we've got our BP third person character here, and under player controller class, we've got BP third person player controller. And if you wanted to find that, you could hit browse here, the little browse icon, and it will select the third person player controller. So if you're not working in 5.6.1 or later, this browse button will probably just not take you anywhere because it's just using the base class, which is a C++ class, so there is no asset here. And if that is the case, you will need to create one. So you'll just need to right click and go to Blueprint Class, select Player Controller, call this something like BP underscore my player controller. And then you could just drag this onto the player controller class right here and set it as that one. I'm actually going to hit Control Z and, oh, that didn't work. I'll just drag the third person player controller back onto here and delete this one because I don't need that extra one, but I just wanted to show you how to create one and set it in case you don't have this here. But in any case, once you do have a player controller class here, you can open it up, and then if you select the root here or select class defaults at the top here, you'll see the class defaults over here in the details panel, and under player camera manager class, you can set your own player camera manager class here. So this is the base class, but instead of using the base class, what we can do is create our own by just right clicking in here, creating new blueprint class, dropping down all classes, and we can search for player camera and create a player camera manager class by selecting this, hitting select, and we'll call this BP underscore my player camera manager. And then once this is created, we can just go into our player controller here and player camera manager class and set it as this one that we've just created, BP my player camera manager. And now that that has been done, if we open up this player camera manager and have a look in the class defaults here, we can change all sorts of things with the player camera manager. But just to give an example, the one I want to draw attention to here is view pitch min and view pitch max. And this is basically the maximum and minimum angles that you can look up and down with your player camera. So if we set this to something like -70 and 70 and hit compile and hit play, now when we look up or down, we can't look up or down beyond +70 and -70 degrees, which in my opinion does feel a lot nicer. And it depends on your game. You know, maybe you're doing a third person shooter where you've got a lot of verticality and you want to, you know, allow your player to aim almost straight down or straight up. But in my case, I think this looks much, much nicer. And guys, that pretty much covers it for just the sort of basics of improving the third person camera in the third person template, the things that I wanted to touch on. But now I'm going to go ahead and show you a few more things that you can do that will be especially handy if you're making a third person shooter to improve the behavior of your third person camera. So if we open up our BP third person character and head to the event graph, and I'm just going to close the player controller and the player camera manager because I'm not going to mess with those anymore. I'm basically going to show you how to set up aiming with sort of rotating the character towards where you're facing when you are aiming, and, you know, lowering the maximum walk speed and lowering the field of view of the camera and stuff like that to work in a very, very smooth way that will work well for third person shooters. So first things first, we're going to need an input action for aiming. And what I can do is I can actually just double click on IA jump here, which will open up the input action for jumping. And then I can hit browse here and browse to the input actions folder. And I'm going to go ahead and press Control D and duplicate IA jump because it has the settings that we need. And I'll just call this IA aim. And the only other thing I need to do is add this to our input mapping context and add some bindings, some keys or buttons that we can press to activate this IA aim. So if we back out to the input folder here and open IMC default, this is the input mapping context that is assigned when you begin play, and it contains most of the regular input actions. And we can go ahead and add our IA aim to this. So we can add a mapping here and we'll select our IA aim. And then I'm going to drop this down. And if I click this little keyboard icon, it will then allow me to press whatever key I want to map to IA aim. I can press the right mouse button and I can map the right mouse button to IA aim. But I've got a controller here and I also want to have an input on controller for IA aim. So I'm going to add one more here. And then on this second one, I'm going to click the keyboard icon. And on my controller, I'm going to press the left trigger. And it will set that as the gamepad left trigger axis. So I can also press the left trigger or L2, whatever you want to call it, to aim, as well as the right mouse button. And now that that is done, I can save this and I can close this. I can also close IA jump. And here in the event graph of my third person character, I can search for IA aim and bring up my IA aim. And I'm going to drop this down. And the first thing that we're going to need here is a Boolean, a variable that tells us that we are indeed trying to aim, that we are pressing the aim button. So we can add a variable here and I'll call it aiming ? And it will be of type Boolean. And then I'll hold Alt and click and drag this out to get a set node. I'll press Control D to duplicate. And on started of IA aim, I'm going to set aiming to true. And on cancelled or completed, I'm going to set it back to false. So that when we're pressing the right mouse button or L2, aiming will be true. And once we've released it, it will be set back to false. And guys, as always, when you're setting up an input action, I highly recommend just printing this out to make sure that it's working. So we can drag off of here and get a print string, and I'll plug both of these into the print string, and then I'll get my aiming variable and plug it into the in string like so. And now we'll be able to see if this is, firing the correct number of times and correctly setting this Boolean when we press and release the aim. So I'll hit compile and I'll hit play. And when I press the right mouse button, it should say true up the top left, which it does. And when I release it, it should say false. So if you want your logic to only execute once, you want to just test this and make sure that it only says true once and it only says false once, so that you're not executing your logic more times than it should. But now that we've tested that is working, we can delete that print string. And let's go ahead and add a very simple function to this, which will lower our walk speed when we are aiming. So I'll create a new function here and I'll call it update max speed. And in this function, we're going to get our character movement here, and we're going to set max walk speed. Plug this in here and drag off of the float input here, and we will get a select float. And what this does is if this takes a Boolean, and if it is true, then this will select whatever is plugged into A. And if the Boolean is false, it will select whatever's plugged into B. So we can get our aiming Boolean and plug it in here. And now if we are aiming, our max walk speed will be A. And if we're not aiming, our max walk speed will be B. So we can select the character movement component here, and if we have a look for max walk speed, you'll see the default max walk speed here is 600. So let's just make our default max walk speed 600. So if we're not aiming, it will be B, so this will be 600. And then if we are aiming, we'll set this to something like 150. But just in case you want to change either of these, we'll promote them both to a variable. So we'll drag off of B here and promote to variable, and we'll call this default max speed. And we'll also drag off of A here, promote this to a variable, and we'll call this aiming max speed. And just in case you want to change either of these, including the default max speed here, which is obviously the same as the default max speed in the character movement right here, instead of having to worry about changing this in multiple places, what we can do is just set the default max walk speed in the character movement component within the construction script of our character's blueprint, so that you only need to change the default value of this right here. And if we compile here, we can check the default values here are whatever we put in the boxes here before we promoted them to a variable. So default max speed is 600 and aiming max speed is 150. So I'll show you how to set this up so that you will only need to change this right here in the default value of this variable, and you won't have to worry about whatever's in here in the character movement component. So to do that, what we want to do is get this default max speed, and I'm also going to hold Control and grab these two nodes here as well, and then Control C to copy. I'm going to create another function, and I'll just call it set defaults, something like that. I'll hit Control V to paste these in, and I'll plug these in like so. And then I just want to call this function in the construction script. So if we head to the construction script, we just need to call that set defaults function. And now basically whenever you make any change to this blueprint in the level, or like this construction script is just, this fires anytime you make any change, basically. So this will happen even before begin play. So the defaults will be set. So I digress. We covered that. But if we go back to our event graph, now that we've created this update max speed function, we can just call it on pressed or released of IA aim. And once again, if we double click this and open this up, all this does is set the max walk speed in the character movement component as either the aiming max speed or the default max speed. So if we hit compile now and we hit play and we start moving around, if I press the right mouse button, our max speed is lowered like so. And if we release it, it increases. And if I pick up the controller, I can also press the left trigger and it has the same effect. Nice. So let's go ahead and add a change of field of view to the camera when we hit aim. And to do that, we're going to use a timeline. But first, I'm just going to hold Alt and click here and delete this connection. And I'll right click up here. I'll add a timeline right here, add timeline. And I'll just call this FOV timeline for field of view. And when we press the right mouse button or the left trigger, we are going to play this timeline. And when we release, we're going to reverse it. And you'll see sort of what that looks like in a moment. But just before I do that, what I'm actually going to do is drag off of this set node and press S to get a sequence. And I'm going to do the same down here. And basically, the reason I'm doing this is just to call this function whenever we press or release the right mouse button or the left trigger. I want to update the max speed. So I can do this by plugging both of these in like so. And then this will plug into, this will plug into play. And this will plug into reverse. And that means that every time we press the right mouse button, this timeline will play and the update max speed function will be called. And also when we cancel or complete this input action, the timeline will be reversed, and the update max speed function will be called. So this will be called on both pressed and release, and the play and reverse will also be called on here as well. So basically what this timeline is it will play and it will output a float, and we're going to use that float to lerp or linear interpolate the field of view of our camera. So if we double click on this timeline node, it will open it up, and here we can set the length of this timeline. I'm going to set it to 0.15, so it's going to be very quick and snappy, but you can always play with the length to suit your needs. And I will add here a float track, and I'll just call this FOV alpha. And I'm going to hold shift and click here twice to create sort of two keyframes in here. Whoops. And the first one I'll set to time 0 and value 0. And the other one, I'll select it and I'll set the time to the maximum time, the length of this float track, which is 0.15, and set the value to 1. And then I can click these two little buttons here to sort of center the view around all of my keyframes here. Now, you could smooth these out by selecting them, for example, and changing this to auto, and you'll get these little widgets that you can sort of change this and you know, make this smooth out, like ease in and ease out. But I'm just going to keep mine linear because it's only very, very short timeline anyway, so you won't really notice any smoothing. And I don't think you'd really want it for an aiming mechanic anyway. So now that this timeline is set up, we can close it. And I'll close set defaults and update max walk speed for now as well, and just go back to the event graph. And now you'll see that this timeline has an output here, which is the output of our float track, which we named FOV alpha. And what we can do now is we can grab our follow camera. And if I drag off of here, I can set field of view. I plug this into update here, and now basically as this timeline runs and the float output updates, it will fire off anything that's plugged into update right here. And what we want to do is drag off in field of view, and we'll get a lerp node, and the alpha will be the output of our float track here. And basically what this means is that when this float track is outputting 0, we will be at A, and as it moves from 0 to 1, it will lerp between A and B. So this will sort of smoothly set this as the range from A to B, if that makes any sense. So A will be our default field of view, which if we select the follow camera, we can check the field of view here, and it is set at 90. So we can put 90 in here, and let's lerp it down to something like 50, just so it's super, super noticeable. And once again, in case you want to change these values later on, what we can do is promote this one to a variable, and we'll call it default FOV. And we'll also promote this one to a variable, and we'll call this one aiming FOV. And you might want to even go a bit deeper and, you know, create different aiming FOVs for different weapons and whatnot. But I'm just showing you the basic setup to sort of make this work nice and smoothly. And I'll compile now, and I'll just check the default values of these are correct, 90 and 50, very good. And now when I hit play and I hit the right mouse button, we see our camera is kind of zooming in and then zooming back out when we release. And we've even got that lower walk speed when we aim. Nice. Now, one more thing before I forget is that if you do want to change these later on, we want to do a similar thing where we set the defaults in the construction script so that you only have to change the default FOV here, the default value of it, instead of changing it in the details of the camera. So we'll get the default FOV node here and both of these nodes up here. We'll Control C that, and then we'll open up our set defaults function. And what I'll actually do is just drag off of here and press S to get a sequence. I'll paste in those nodes and I'll plug this into the next execution pin on the sequence, plug in default FOV, and then on construct of this blueprint, we'll be setting the max walk speed and the default FOV of the camera. And just to check that that's worked, for example, we can change this to something ludicrous like 150. And if we hit play, we'll have a really wide FOV and our, our aiming zoom will still work as intended. Nice. So I'll just change that back to, I'm going to make it 80 actually, because I think a little bit lower than 90 is much nicer. Sort of stops everything from stretching, especially when you look up and down. And now that we've set that in here, I'm going to close set defaults again. And I'm going to come back to this timeline shortly and add some more stuff that rotates our character and sort of changes the movement characteristics, you know, based on whether you're aiming or not. But first, I'm just going to show you how to set up aiming and looking sensitivity controls so that you can change the sensitivity of looking around. So you want to find IA look and IA mouse look, because these are the two input actions that we're concerned with here. IA look is bound to the right thumbstick on gamepad, and then IA mouse look is separate, which I do recommend. If you look in the input mapping contexts, you'll see what these are bound to. And basically the reason is to give you dead zone on gamepad, a little bit of a dead zone on the right thumbstick, which you don't need on mouse look. But there's other things that you'd want to separate between these two, such as sensitivity settings. So I'm just going to make this section quite a lot bigger, and I'll move these out here to on the left like so. And let's first have a look at IA look, which, as I said before, is the gamepad input. I'll move this aim call to this aim function out here. And by the way, if you're working in earlier versions of the engine, you won't have this aim function. But if you double click this, what you'll see is the nodes that you would see in earlier versions of the third person template. So when we do this input action, it is just calling these add controller yaw input and add controller pitch input nodes. But basically, whatever the action values are plugged into here off of the input action, right here is where we're going to be doing the work. And basically what we're going to do is just multiply these action values by a number to sort of change the sensitivity of our aiming. So we can drag off of action value X here and find a multiply node. And I'll plug this into the X axis like so. And I'm going to do the same with the Y, find a multiply node and plug this in here. And then what we're going to multiply this by is our sensitivity. But we're going to want a different figure for horizontal on gamepad, vertical on gamepad, and also you probably want sensitivity controls for aiming as well. So we'll also put in controls for that. So we can drag off of this input pin right here and once again get a select float. And here we'll grab our aiming boolean and plug this in here. And then we can actually duplicate both of these and plug this one into the Y value. And these four inputs here will be our horizontal aiming, horizontal look, vertical aiming, and vertical look sensitivities. So I'll start with the look sensitivity, and you can make these values whatever you like, but I suggest following along to sort of see what I'm going for here, and then you can go ahead and change them later. So if we multiply this by 2.2 and this by 1.6, I've found that this is because the sensitivity of the gamepad look by default, I think is a little low. So I like to ramp these up quite a bit. So 2.2 and 1.6. And then for aiming, I would make it 0.8 and 0.6. And the reason these are not the same, by the way, is because usually you'll have higher sensitivity horizontally because, you know, that's what players are doing most of the time. They're trying to spin around, and then the vertical sensitivity is a little bit lower. So let's go ahead and promote all of these to variables. I'll do this one first, promote this to a variable, and this will be our horizontal sensitivity gamepad, and I'll just select that name and Control C to copy, and then I'll promote this one to a variable. I'll paste in that name, except I'll call this one horizontal aim sensitivity gamepad. You can name these whatever you want, just to distinguish, you know, what each one actually is. And then I'll do this one next, promote that to a variable, paste in that same name, but this time I'm going to change it to vertical sensitivity gamepad. And then I'll Control C that name, promote this one to a variable, paste in that name, and this one is vertical aim sensitivity gamepad. And there's no need to set these in the construction script, because this only fires when you actually, you know, move the mouse or the right thumbstick in this case. So that is all set up now, but we just need to do the same for our mouse look down here. So I'll move this way out here, and to make this a bit easier, I'll just select all of these nodes here that we created. I'll press Control D to duplicate them down here, and I'll plug action value X into here and plug this into here. Action value Y goes into here and this one into here. And then I'm just going to go ahead and duplicate all of these variables for mouse looking. So I'll get horizontal sensitivity gamepad, duplicate that, and just replace gamepad with mouse. And I'm going to go through each one of these and do the same. Replace gamepad with mouse, vertical sensitivity mouse, and vertical aim sensitivity mouse. And then I need to replace these nodes here with the appropriate ones for mouse. So horizontal sensitivity mouse goes here, horizontal aim sensitivity mouse goes here, vertical sensitivity mouse, vertical aim sensitivity mouse, and then all I need to do is change the default values of these variables. And the mouse input is a lot touchier, so these will be quite different, but what the values that I've found to work quite well: horizontal sensitivity mouse, I actually have to compile before I can set the default values of these. Horizontal sensitivity mouse, I'll make 0.8. Horizontal aim sensitivity for the mouse, I will make 0.35. And then vertical sensitivity mouse will be 0.6. And vertical aim sensitivity for the mouse will be 0.3. And once again, you can change the values of these however you like, but these are the values that I like. So if I hit compile now and I hit play, we'll see we've got different sensitivity on the mouse. It is much less fast than it is by default. And if I right click, it slows down as if I'm aiming. And I've got that different sensitivity when I'm aiming. And I can pick up my gamepad and do the same thing. If I press L2, I've got much less sensitivity when I'm aiming. And that feels very good indeed. And there's just a couple of other things I'd like to add to this aiming function right here, so that our character sort of looks wherever you're aiming, because at the moment, you know, the character just, it's called orient rotation to movement. So the rotation of the character is just going in the direction of wherever the character looks. But I'm going to make it so that when I aim, my character rotates and looks wherever the camera is looking. So what we're actually going to do to achieve this is on update here, when this timeline plays, we're going to change the rotation of our character. So we can drag off of here and set actor rotation. And off of the new rotation here, we can find a lerp rotator. And you'll see here the option for shortest path. And this is very important. This means that the character will always rotate, the correct way around when she turns around. But to get a starting point for this rotator, because we don't want to sort of change the starting point on tick here on update of the timeline, we want to set this before we play this timeline. And that's where whatever we've plugged into here comes into handy, because whatever we add on to the end here of update max speed will run whenever we press or release the right mouse button or the left trigger. So what we can do is right click here and get actor rotation. And I'll promote this to a variable and I'll just call this current rotation. Plug this in here, and now whenever we press or release the right mouse button, it will set this variable as wherever the character is rotated. And we can use that current rotation as the A on our lerp rotator here. And then for the target rotation, we can get our follow camera, and we will get world rotation of our camera. But we only need this on the z-axis, because we only need to see sort of which way the camera is looking on this rotation. We don't want to rotate our character to be like looking down or looking up. We just want to spin them on this axis, which is the z-axis. So we can right click here and split this struct pin. And we can also do the same on the lerp rotator to split this into the 3 axes like so. And all we need is the yaw, the z-axis, like so. For the x and y axes, we can duplicate this current rotation, the get node, getting this variable. We can right click here and split the struct pin on that one. And then we'll just use the x and the y from the current rotation, like so. And we also just need the alpha, which comes from the timeline here. So I'll double click here to get a reroute node. And I'll plug that into the alpha like so, and that should all be working now. But once this timeline is finished and our character has rotated all the way to the direction that the camera is facing, we want to change the movement characteristics of the character, otherwise they'll just start rotating again when you start moving. So what we can do is we can create a new function, and I'm just going to call this one update movement. And in here, what we're going to do is get the character movement component, and we are going to set orient rotation to movement. And this is the option that basically decides whether your character's rotation should update based on which direction they're moving. And we only want that to happen when we're not aiming. So what we can do is we can get our aiming variable. We can also get a not boolean and plug this in here. And so this will be set as the opposite of whatever aiming is. If we are aiming, then orient rotation to movement will be off. And if we're not aiming, it will be on. I'll just move this out here and put these here. And the other thing we want to do is set something called use controller rotation yaw. So we can search for set use yaw and set use controller rotation yaw. And this basically just makes the character face in whatever direction you're looking with the controller, with your camera. So we can plug this in here, and this, we want it to look in the direction of the camera when we are aiming. So we can just plug the aiming variable straight in like so. And now we just need to call this function. So we'll go back to the event graph. And for now, I'm just going to call update movement on completion of this timeline, on finished, like so. We'll improve this in a moment, but I'll just show you how this will work now. So as this timeline updates, the character will rotate, and when it's finished, it will set those movement variables accordingly. So I'll hit compile now and hit play. And now you'll see as I run around, the character's rotation is oriented to its movement. But if I right click, the character will rotate in the direction that the camera is facing, and it will stay facing that way while I'm aiming. And then if I release it, she'll turn around and start orienting her rotation to the movement again. Nice. Now, there's only one problem with this setup. Running that update movement function on completion of the timeline works fine when you're aiming, but when you're releasing aim, she won't turn around until that timeline is finished. And that might be okay for your game to have that little bit of a lag between releasing aim and turning around. But depending on how you want to set it up, I can also show you how to make her turn around right away. So it's basically about when this is called. And we'd only want to call it on finished if this timeline is playing forward. If we're playing it in the other direction, i.e. when we release aim, we'd want it to play at the beginning. So what we can actually do is disconnect this, and right here we've got this enumeration output direction. If we drag off of here and get a switch on this direction and then plug in finished like so, we can now only fire this when the timeline has been played forward. And when we release the right mouse button, we can also call this function at the start. So we'll just duplicate this call to the function down here, and we can just add an execution pin to the sequence right here and plug this in. So a good way to think about these sequences is anything that you want to play or run, execute, when you press the right mouse button, you could plug into this sequence, and I'll just remove that. And anything you want to execute when you release aim, you can plug into this sequence, i.e. the update movement node, like so. So I'll hit compile now, and if I hit play, you'll see that she rotates when I aim, and when I release, she'll just turn around and start running in whatever direction immediately. Nice. And this should all be working pretty smoothly. It won't matter if you spam it, if you press it when you've just released it. The behavior shouldn't be broken in any way, no matter how you play this game. And that's pretty much it, guys. That's all we set out to do today. I think this is a vast improvement to the camera setup in the default third-person template. We've got looking up and looking down, and the character sort of stays on the left-hand side of the camera. We've got view, pitch, min, and max. We've got this changing FOV and changing walk speed when we aim. And we've even got this change of movement modes depending on whether we're aiming or not aiming. I think that is really nice. That's it, guys. If this tutorial has been of any use or value to you whatsoever, please hit like and subscribe, and I will see you on the next one.